Welcome, pre-calculus students, to the unit circle. It's what we've been waiting for, the unit circle. So let's go into it real fast here. The unit circle is, of course, with a radius equal to 1. So if we graph this on an xy axis, this would be 1, 0. This would be 0, 1. And if we kept going around, this would be, what would this be, guys? Negative 1, 0. And this would be 0, negative 1. Okay, so that's basically, if you think about it, the truth, because this black line from here over to here is equal to 1 unit. The question is, how long is this purple line? Well, that's actually 1 as well, because it's still a radius going around. What we're going to do, though, is look at what these 6 spots here, or sorry, 8 spots on the graph represent in terms of radians. Now, if I make this right here equal to 45 degrees, and I want to know how many radians 45 degrees is to practice what we did last night. If we start off with 45 degrees, we put that over 1, and then we multiply this. And you guys got to remember, you're either going to multiply by pi over 180 or 180 over pi. So which is it? If I'm converting this to radians, it is going to be pi over 180. And that's because I need pi to be on top. So this would cancel, and actually 45 goes into 180, it looks like 4 times. So this would be pi over 4. So right here, we're going to label this, and in color it's going to really stick out like green. We're going to call this pi over 4. That's 45 degrees. We know that this starting point here is going to be 0, or if we do 1 full revolution all the way around, that's going to equal 2 pi. So sometimes that's called 0, sometimes it's called 2 pi. I'm going to let all the green stuff I'm going to write on here equal the radians. So what I'd like you to do now, if you're watching this for the first time, is try to get this one right here. You got to know how many degrees that is, and of course it's going to be 90 degrees all the way around. And 90 degrees times pi over 180. Do a little math here, canceling. This will be pi over 2. So this is pi over 2. Like I was saying, if you're watching this for the first time, go ahead and hit pause. And what I want you to do is try to figure out what this is, this is, this is, this is, and this. And try to label these all the way around. Go ahead and hit pause and try to figure that out. Now, the answers to this, because you guys watching the second period are just going to see the answers. But basically, these are all increasing by intervals of 45 degrees. This is 45 plus 45 is 90, and I'm going to add another 45. So if you think about it, this is just 1/4 pi. 1/4 plus 1/4 is 1/2. Now what's 1/2 plus 1/4? Well, that's 3/4. So this is 3 pi over 4. And I keep adding 45 degrees to this. These are all 45-degree angles here. So if I add another 1/4 to that, it's going to equal 4/4, which is just pi. That's why half a spin is equal to pi, like we did earlier today. If I keep going around, we could just add 1/4 to this. So 1 plus 1/4 is 5 pi over 4. This will be 6 pi over 4, which reduces. 6 over 4 will be 3 over 2. So that's 3 pi over 2. So that's 6/4. This will be 7/4. 7 pi over 4. And this is, of course, 8 pi over 4. And 8 over 4 is 2 pi. So we can see that the degrees and the radians match up. So let me put the red numbers in here. So this will be 90 plus 45, 135. 180 plus 45 is 225, 270, 315, and 360. And you can see that these angle segments represent these green radian segments because they're equal. You can practice this by saying, okay, if I take a 270 degree angle, just to show you how to practice this, 270 degrees converting to radians, I would multiply that by pi over 180. And if I did all the canceling correctly, this would be 3 here and 2 here, because 90 goes into each one of these. It's going to be 3 pi over 2, which is what we have right there. This is the unit circle. Now tomorrow, we're going to bust this up into 30 and 60 degree chunks, and I'll have you do it in class as an exercise, and then I'll show you the next level of this. You guys have a fantastic day.